If you like my video, please share to your friends, subscribe, and for the new video notifications, please press the bell icon and don't forget to follow our Facebook page. The link is given in the description. Thank you. Hi friends, this is Anusha. In the topic of reflection of light at curved surfaces, we are dealing with now concave and convex already completed. Now we are coming with a new video. In that we are going to learn about the rules in convex mirror. So for the convex mirror, what are the rules you need to follow? Let us discuss now. So suppose this is a convex mirror. This is a convex mirror, right? So where will be the mirror? This will be the mirror. Where will be the pole? Pole. Center of curvature will be here, isn't it? So the line joining both the pole and the center of curvature is nothing but your principal axis. Principal axis. And this is your pole. This is center of curvature, or where all the normals meet, you can say. Center of curvature. And this is what? Focus. So let us see the rules which we will follow to draw image formation in the convex mirror. So is this convex or a concave? If you draw like this, yes. Now it is convex mirror. Which mirror it is? Convex mirror. Why? The mirror is outside. Outside. The mirror is outside, isn't it? Like this. Bulged outside, you can say. So it is what? Convex mirror. So what it becomes? It becomes pole. And what it becomes? Focus. And what it becomes? Center of curvature. Now the first rule. When a ray is traveling or incident, you can say incident on convex mirror parallel to principal axis. Parallel to principal axis. The rule is same with the concave. Then it passes through what? It seems that it got reflected and passes through focus. Isn't it? Now let me draw. This is what I can draw. I can say this is incident ray. So I said, isn't it? When it travels parallel to the principal axis, it seems that it is, when you see from here the mirror is, isn't it? If your eye is here, from the left side if you see it, it seems that the ray is coming from, coming from this focus. So this is your what? If you draw again, if you extend this line, you can see here the line. This will be your reflected ray. What ray? Reflected ray. It is coming out like this, isn't it? Reflected ray. Mostly we don't use it, but you should know it. A ray is traveling or incident on a convex mirror. parallel to the principal axis. It passes through the focus. It seems that it is passing through the focus. I hope you are clear with this. And coming to second case. Coming to second case. When a ray or incident on convex in such a way that as it is coming from center of curvature. Then it passes the same in the convex. Again it seems to passes from the reflected ray seems to passes from center of curvature itself. Same path it follows. Center of curvature. Same path it follows. Let me show you while in diagram. See. Principal axis. First let me draw the mirror. This will be the mirror. Pole. Center of curvature. Focus. Will be this side. Is this correct for the concave? Yes, correct for the concave. For the convex, it is wrong. It should be where? It should be, this will be your mirror, isn't it? If you don't draw this, you will get confused. Yes. This will be your reflecting one. And here will be the focus. Here will be the center of curvature. So when a ray is passing from center of curvature, when it seems to pass from the center of curvature, that's why it is there, isn't it? When a ray is seen to pass from the center of curvature, it gets reflected back in the same way. It gets reflected back, see, instant like this, isn't it? If you see from here, it seems that it is getting reflected back in the same path of the center of curvature. So this will be your incident ray and this will be your reflected ray. This will be your reflected ray. When you look from here, actually it will be, as the mirror is here, here only the incident ray and reflected ray will be there. But when you look from here, it seems that it is coming from center of curvature. It is coming from center of curvature. And third rule. Third rule is that when a ray is seen to passing or it is getting passing from focus F, it seems that it travels parallel to the principal axis. It travels parallel to the principal axis. Now how? See, if the ray, it is incident somewhere here, suppose, when it passing from the focus, suppose, then it travels back parallel to the principal axis. It travels back parallel to the principal axis. When a ray is making an angle with the pole, when a ray is making angle with the pole, see, it reflects back with the same angle. It reflects back with the same angle. As you know from the second law, isn't it? Angle I is equal to angle R. Angle I is equal to angle R. So these are the 4 rules you need to follow while drawing this convex mirror. Drawing. Now, let us take one case. When object is kept in the convex mirror, this is the convex mirror. Or, let us see what are the cases in the case of convex mirror using rules. Suppose, see, this is the object AB. What is this? This is the object AB. This is what? Object AB. Where it is placed? In front of the mirror it is placed, isn't it? If you want to get any image, if you want to get your image in a mirror, you need to stand in front of the mirror. If you stand back, you can't get it, isn't it? So, you are putting an object in front of mirror. So, the rays will come, isn't it? The source you will keep. So, the rays are going to come. The first ray is traveling parallel to the principal axis. Traveling, this is what your incident ray. Incident ray. How it is coming? Parallel to the principal axis. How it is coming? Parallel to the principal axis. So, it seems to what? When a ray travels parallel to the principal axis, the reflected ray seems to fall from where? From focus. And here another ray 2. This is ray 1 and ray 2. Ray 2 is coming from it seems that it is coming from the center of curvature. What is the rule for the center of curvature? If it is coming from the center of curvature, it is reflecting back with the same path. So, these two behind the mirror. This is in front of mirror, isn't it? This is the in front mirror. This is what? Back of the mirror. Oblique lines always says what? This is back of mirror, behind mirror. Back of mirror or behind mirror. So, where the image forms? Here, back the mirror, the image forms. This is your image. What is this? This is your image. What is this one? This is your image. What is this? Image. It is what? Image. So, another ray. These two rays, really they are meeting? No, they are not meeting really. If they don't meet really, which image you will get? You will get a virtual image. If they don't meet really, what you are going to get? You are going to get a virtual image. Always remember, virtual image will be always erect. Virtual image will be always erect. And the virtual image here is diminished. Means small image. In this lesson, diminished means that it is small image. Where the image is formed? Behind the mirror it is formed. Once again I am repeating. Concentrate on this. See, this is your convex mirror. This is the back side of the mirror. This is front part of the mirror. So object is kept obviously in the front of the mirror. So what happens when a ray travels parallel to the principal axis? It seems that it is passing from the focus. It gets reflected back from the focus, it seems. So it is coming from as it is back of the mirror. I am representing with dotted lines. This is the reflected ray. Ray A is meeting the mirror at D and reflecting back at X, and it passes through the focus. Ray A is meeting suppose if I keep B here. Ray B is meeting the mirror at E. Meeting the mirror at E. Which mirror? This is the incident ray. And it seems that it is passing from the center of curvature I am taking. So the same path it comes back. So here this reflector ray and this reflector ray is meeting here. Where the two rays meet, there the image forms. So here the image is forming. Image I am representing as A dash, B dash. It is erect image. Erect means straight image. How my image is the same I'll get it. But in size it will be different. The same, not inverted. Like in the case of concave, it is not inverted. It is erect. And this is the one case. And another case is when I keep some object at infinity. And some objects, let us say you stand here, see the far away object. How the image will be? Point image it will be formed. Here, like that, it is diminished image is formed. So this is the ray A is meeting the mirror at D and reflecting back at X. Ray A is reflecting back with the same angle Y here. Okay. And next, these two reflected rays are meeting here. So here, highly behind the mirror, the image is formed. Virtual and erect. Virtual means as the rays are not meeting really, we are making it to meet. It is a virtual image. And erect image is formed. Highly diminished image. Very small image it is formed. And if you see something from here to if you put your mirror and show, if let me say 3-4 meters away. So the image formed will be point, and diminished means very small. I hope these two are the cases which we deal with the convex mirrors. So if I keep a object between pole and the focus, if I keep a object, then where the image is formed. If I keep here, the image is formed between pole and focus. So, when object is kept between infinity and the pole, infinity means somewhere else. If infinity and the pole. So, where the image is formed between pole and the focus, how the image will be? Virtual and erect. Diminished, very small image will be formed. And at the infinity, very point size image is formed. So, let me tell you a clear way. So, one thing, till now we discussed about concave, convex mirrors, rules, how to follow to draw the image and all. Now, let me put that all the summary in a table so that you better understand. So, let me go with the table now. Now, first I'll go with the table in the cases of concave mirror. So in the cases of concave mirror, within the focus, if I put I have 5 columns here. Position of the object, position of the image, size of the image, size of the object. If you remember this table, you can easily, and rules and this table. If you remember it, easily you can draw the ray diagrams and very easily. The lesson full of this itself. Don't get confused, be clear when you are studying this, so that you can do the problems, you can do everything. So first, let me tell you. First one, position of the object. Where the object, always the object will be kept to the left of the mirror, mostly left of the mirror, and in a erected manner only it is kept. First, within the focus. Here it is kept. Within the focus means within the focus between P and F. Here the object is kept. Then, where the image is formed? Behind the mirror. Behind means back of the mirror. Here the image is formed. And how the image is? Enlarged. How the image is? Big image, enlarged image. As it is behind the mirror, the rays are not meeting really, we are making it to meet, isn't it? That's a virtual and erect image will be formed. Next, at focus. Next is at focus. If I keep the object at focus, then where the image position will be? At infinity. Where the image position will be? At infinity. How the image at infinity? You can draw it? No, you can leave it. You need not to draw at infinity where it is formed. You need to, those two rays, you are not supposed to draw any image there. How the image will be? highly enlarged. And at infinity also, how the size of the object will be? Real and inverted. Size, real and inverted. Next, between F and C, if I keep between F and C, between focus and center of curvature, where the image is formed beyond C here, beyond C. How the image will be? Enlarged. How the image will be? Enlarged means big image will be formed. Enlarged image. Highly enlarged, very big. This big. Real and inverted image. Yes, rays meet really. Where the rays meet really? Beyond the sea. Beyond the sea. At C. If I keep the object at C. If I keep object at C. Where the image is formed? At C. Where the image is formed? At C. How the image will be size? Equal to the object. If the object is of 4 centimeters, image will be also at 4 centimeters. How? Their rays are really meeting. So real and inverted. Beyond C if I keep. Beyond C if I keep. Where the image is formed. Between F and C. How the image will be diminished. See here. At between F and C if you keep. Beyond C it is formed. Enlarged. Real and inverted. Beyond C if you keep. Between. This is quite opposite to this case. This fifth case is quite opposite to third case. Between F and C, how the image will be diminished, small image will be formed. And real and inverted, the rays meet really. And the image will be inverted like this. If the object is like this, image will be like this, inverted. If the object is like this, inverted, image will be like this. At C, same size, but inverted. Next. At infinity. If I keep at infinity, see here. This second case and sixth case are again. At infinity, at focus, if you keep the object at infinity, the image is formed. At infinity, if you keep the object at the focus, the image is formed. It will be highly diminished and it is also real and virtual. And let me show you now how in the case of convex, only 2 cases we have discussed, isn't it? 2 cases. A chart I'll draw and I'll show you how the convex mirror behaves. In the convex mirror you are going to see now. Only 2 cases are important here. Let me show you that. This is the convex mirror, isn't it? This is the pole, this is the focus, this is the center of curvature. And anywhere between pole and the infinity, between the pole, infinity and the pole, if I keep somewhere here the object. Where the object image is formed, after falling here, after getting reflected, when the 2 rays meet, that is called image, isn't it? Behind the mirror, between P and F, behind the mirror here, P and F here, the image will be formed. And it will be diminished, very small, virtual and erect. Virtual, as you know, in the convex mirror, the rays are not going to meet really, they are going to meet only virtually. We are making it to meet, so it is diminished. And next, at infinity, behind the mirror, at infinity, if I keep the image at infinity, not between P and F also, at infinity, between the P and F only, if you keep, between the P and infinity, if you get diminished, at the infinity, if you keep, you will get a highly diminished image, always virtual and erect.